Hi friends, welcome to the next session of the subject Engineering Mathematics, Chapter 1 Linear Algebra. The concept is System of Linear Equations. As I mentioned in the last session, the system of linear equations is represented by Ax equal to b. If this system has at least one solution, then it is called a consistent system. Otherwise, it is called a inconsistent system, right? Now, when I have a large number of equations involving more number of variables, it is not so simple to solve for various number of variables. Even that is not our task also. Our task is whether it is consistent or not. If it is consistent, how many solutions are there? See, consistent means if it has at least one solution. Suppose if the system of equations have more and more number of solutions, then that is also called as consistent. So in consistence, we have two categories: consistent with a unique solution, and consistent with infinite number of solutions. Now we need to discuss ranks of various matrices to discuss whether the system has unique solution or whether the system has infinitely many solutions. If the system has no solution at all, then it is called inconsistent. Therefore, in order to discuss these things, we have three different cases. But before discussing these three cases, let me tell you classification of linear equations. So classification, that means there are two types of system of linear equations. One is Ax equal to b, another is Ax equal to O. Here O means what? Null matrix. That means if RHS of every equation is 0, then such equation is called, the system of equations is called homogeneous system of linear equations. Such system is called homogeneous system of linear equations. So there is some advantage with homogeneous, we will discuss after some time. Now right now we discuss non-homogeneous. That means if the right hand side of every equation, or at least if one constant on the right side is non-zero, that is called non-homogeneous. If the RHS of every equation is 0, such system is called homogeneous system, right? Now two classifications, one is non-homogeneous, another is homogeneous. Right now we discuss non-homogeneous system of linear equations. So in case of non-homogeneous, we have three different cases: consistent with unique solution, consistent with infinite number of solutions, and the third one is inconsistent. Let us discuss three different cases to analyze these points. Suppose I am starting with an example. Suppose x plus y equal to 8, 2x minus y equal to 7. So keeping x value 3, x value 5, y value 3 in my mind, I have set these two equations. 5 plus 3 equal to 8, 2 into 5, 10 minus 3 equal to 7. So these system of equations have exactly one solution. So x takes single value, y takes single value. If all variable takes single values, then it is called a unique solution. Therefore, in this case, the system takes exactly one solution. Now, let us try to convert these equations in the form Ax equal to b. What is my matrix A? This is coefficient matrix. 1, 1, 2, minus 1. And what is x? Of course, it is immaterial. It is not required for me. Now, b is 8, 7. So what is my augmented matrix? A slash b, and this is 1, 1, 8, 2 minus 1, 7. The size is 2 by 3. Now let us see what is the rank of A. It is a 2 by 2 matrix whose det is not equal to 0. Its det is minus 3. For a 2 by 2 matrix, det not equal to 0 means its rank is 2. Even you can discuss rank of augmented matrix. Even its rank also equal to 2. What about number of variables? So in this system of equations, the number of variables is 2. Therefore, rank of A equal to rank of A slash B. That means it confirms that the system is a consistent system. So whenever rank of A equal to rank of A slash B implies the system AX equal to B is called a consistent system. Therefore, AX equal to B is a consistent system. So when rank of A equal to rank of A slash B, the system is consistent. But in consistent case, we have two categories. Consistent means if it has at least one solution. At least one solution means it may have exactly one solution or it may have infinitely many solutions, right? So when rank of A equal to rank of A slash B, it is consistent. But interestingly, here number of variables also equal to 2. Therefore, when these two quantities match with number of variables, then it is consistent, having exactly unique solution. So that is the reason this two system of equations possess exactly one solution. So what is the condition to get consistent at first? If rank of A equal to rank of A slash B, then it means that the system is consistent. The system is consistent. If they match with number of variables also, both the quantities are same, it confirms that it is consistent. If they match with the number of variables, then it is consistent, having exactly one solution. So I think you understand. Did you understand why we are comparing these two quantities with number of variables to confirm about number of solutions? If both the ranks are same, rank of quotient matrix, rank of augmented matrix, it clearly indicates that the system is consistent. If they both match with the number of variables, what does it mean is it has exactly one solution, right? Note these points. Case 1. If rank of A equal to rank of A slash B equal to number of variables, if rank of A equal to rank of A slash B equal to number of variables implies AX equal to B is consistent, AX equal to B is consistent and has a unique solution, and has a unique solution, and has a unique solution. You need not worry about these examples. It is not required to note down these examples. Now this is case 1. If rank of A equal to rank of augmented matrix equal to number of variables, the system is consistent and possesses exactly one solution. Now let us discuss case 2 by sample example. Suppose my equation is x plus y equal to 8. Now let us multiply this equation with any non-zero number, any number. Suppose I am multiplying this equation with 2. So 2x plus 2y equal to 16. Now here A equal to 1, 2, 2. So here rank of A, its det value is 0, rank not equal to 2. But this is not a null matrix, so rank is 1. So the same case with augmented matrix A slash B also. This is 1, 1, 8, 2, 2, 16. Now this is a 2 by 3 matrix. Therefore, in this case also, the rank of augmented matrix is 1. So both the ranks are matching. Therefore, the system is consistent. That is very clear. But how many variables are there? NV. Here NV stands for number of variables. So it is exactly 2. So both the ranks are matching, but those are not matching with number of variables. That means it is consistent, having infinitely many solutions. Now let us see why these two equations have infinitely many solutions. Here the one equation is multiplied with 2. So therefore, officially when you look at this, you have two equations. Physically, you are getting two equations on the board. But officially, it represents a single equation, that is x plus y equal to 8. How many solutions will it have? Suppose if I write x value 5, y becomes 3. If it is 0, then this becomes 8. If it is a 10, this is minus 2. That means if x equal to k, some general number, then y becomes 8 minus k. Therefore, when you change frequently the values of k, just assign one value for x or y. So I am assigning one random number to x, for example k, then y becomes 8 minus k. So add these two numbers, it satisfies the given equation. Therefore, when you change frequently the values of k, you will get multiple values of x followed by multiple values of y. Therefore, this system has infinitely many solutions. Infinitely many solutions, random values. Therefore, whenever both the ranks are matching and that quantity does not match with the number of variables, then the system is consistent and having infinitely many solutions. Therefore, the conclusion from this is if rank of A equal to rank of A slash B not equal to number of variables, just I write it as NV, implies AX equal to B is consistent and having infinitely many solutions. And having infinitely many solutions. Note this point 2, very very important. If rank of A equal to rank of A slash B not equal to NB, if rank of A equal to rank of A slash B not equal to NB, implies AX equal to B is consistent, implies AX equal to B is consistent and having infinitely many solutions. And having infinitely many solutions. Now, when you look at these two cases, there is one condition which is very common. Let us see what it is. The common condition is this: rank of A equal to rank of A slash B. It indicates that the system is consistent. Why we are comparing with number of variables? To confirm about number of solutions. So therefore, if rank of A equal to rank of A slash B, it confirms that it is consistent. So when do you say that the system is inconsistent? If rank of A does not match with rank of augmented matrix. Therefore, case 3 we can write directly like this. Case 3 is this: if rank of A does not match with augmented matrix, implies AX equal to B is inconsistent. AX equal to B is inconsistent. Let me give one simple example. Suppose I have an equation x plus y equal to 8. Then let us multiply this equation with any non-zero number. Suppose I multiply this equation with 2x plus 2y. So if I multiply this with 2, this must be 16. But intentionally I am taking a number other than 16. Suppose I am writing 15. Now here what is my A? Coefficient matrix 1 1 2 2. 1 1 2 2. Now what is my augmented matrix? A slash B equal to 1 1 8 2 2 15. Now this is 2 by 3 matrix. Now when you look at the ranks of these two matrices, the rank of A is 1. This is very clear. Now here when you go for rank of augmented matrix, this is a 2 by 2 submatrix whose det is non-zero. For a 2 by 3 matrix, maximum rank will be 2, minimum of 2, 3. Now this is a 2 by 2 submatrix whose det is non-zero. Therefore its rank is 2. Therefore rank of A is 1 but rank of A slash B is 2. Therefore when ranks are not matching, the system is inconsistent. That means it has no solution. See, if x plus y is 8, then 2x plus 2y must be 15. Just take 2 common, then x plus y becomes 15 by 2, 7.5. So on both sides, LHS is x plus y. But here right side is 8, left side is 7.5. When you take 2 common and cancel out the factors. So here it is x plus y is 8. In this case, x plus y is 15 by 2, 7.5. How 8 is equal to 7.5? Therefore, these two equations have no solution at all. So in our terminology, we call it as an inconsistent system. Therefore, whenever rank of A does not match with rank of A slash B, the system is inconsistent. Note this, case 3. If rank of A not equal to rank of A slash B, if rank of A not equal to rank of A slash B, implies Ax equal to B is inconsistent, implies Ax equal to B is inconsistent. So regarding exam point of view, if they ask you questions regarding system of linear equations, these three cases are very, very important. In most of the questions, if it is option based, then questions will be like this. Some system of linear equations will be given. Then in almost all questions, three type of options will be very, very common based on linear equations. Given the following system of linear equations, then the system is option A, consistent with one solution, consistent with infinite number of solutions, inconsistent, no solution. Now three options were there. So to set up fourth option, they may give some different options. Sometimes they may give consistent with 5 distinct solutions. That is not possible in this world. Sometimes they may give consistent with 2 different solutions. Sometimes they may give you inconsistent with 2 solutions, like this. So three options are very common. That is one standard model. Or sometimes they may not give one value as coefficient of some variables, and they may say that if this system is consistent with infinitely many solutions, what will be the value of that variable, for example k, like that they may give. But for all types of questions, these three cases are fundamental cases, very, very, very important factors. Now hope you understand what is the importance of rank. So rank we have discussed maybe in the 4th or 5th session. Now we were almost very close, that means very close to the end of this chapter 1, linear algebra. When you go to large scale industries, they have large number of equations involving large number of variables. So how they handle? They don't handle by eliminating. See, at your lowest standard levels, if a teacher gives you 2 equations in 2 variables, if they ask you to solve these 2 equations, then people will follow one simple technique, that is called elimination technique. By manipulating equations, they will try to eliminate y first or x first. Once they get x value, they will substitute x value in any one of the equations, you get the value of y. That is elimination technique. But that technique may not be so flexible as the number of equations are more and more. In that case, if you want to make analysis about system of linear equations, rank is powerful technique. See, I have 400 equations, 1000 variables. In order to make analysis on its consistency, I don't go for all the things. I will go for writing some code. For example, if I work out on system, computer, then I will go for writing a code, so which gives ranks of matrices. And then when I compare all these, then I will get confirmation about consistency with single solution, or consistency with infinitely many solutions, or inconsistent, no solution. Therefore, rank is very powerful in the analysis of system of linear equations, right? Now this is regarding non-homogeneous. Suppose if I take homogeneous, if I consider the homogeneous part, this is represented by Ax equal to O. What is this O? This O is a null matrix. This O is a null matrix. That means if right hand side of every equation is 0, such system is denoted by Ax equal to O. Previously I wrote B. B means this is not a null matrix. Now in this case B is replaced by O, that means O is a null matrix. Let me write one example. Suppose I have x1 plus 2x2 minus 3x3 equal to 0. So 5x1 minus 9x2 plus 11x3 equal to 0. Minus 7x1 plus 12x2 minus 23x3 equal to 0. Now, you can observe, while I am writing these equations, I don't have any constants in my mind. Randomly, I framed these three equations because my confidence level is right side is 0. But whereas in case of non-homogeneous, keeping x value 5, y value 3 in my mind, I framed those two equations to get unique solution. To get no solution, I multiplied that equation with 2 and right side I wrote a number other than 16. So intentionally, but in this case, my confidence is 0 on the right side. Therefore, can you tell me values of x1, x2, x3 which satisfy all the three equations? It is possible because when you replace x by 0, x2, x1 by 0, x2 by 0, x3 by 0, they fulfill all the equations. Any constant into 0 plus any constant into 0 plus any constant into 0 gives 0. Therefore, you need not worry about coefficients of the variables x1, x2, x3 and so on xn. Therefore, this system is always consistent, which has at least one solution, and that solution is nothing but x1 equal to 0, x2 equal to 0 and x3 equal to 0. And this solution is called as a trivial solution. Trivial solution means silly solution. Without putting any efforts, we got the values of x1, x2, x3. Irrespective of its coefficients, when you replace x1 by 0, x2 by 0 and x3 by 0, they fulfill all the equations. Therefore, whenever you consider homogeneous system, it is always consistent because it has at least one solution, and that solution is all variables are equal to 0, and that is called a trivial solution. Suppose if at least one variable in a solution is not equal to 0, such solution is called a non-trivial solution. Now, you can easily guess, when you are working with homogeneous system of equations, you will not get this case 3. You won't get case 3. Case 3 means case 3 meant for inconsistency. But here there is no chance. That it has no solution. Definitely it will be having solution, and that solution is trivial solution. So if all variables are equal to 0 in a solution, that is called trivial. If at least one variable in a solution is not equal to 0, that is called non-trivial. Generally, we discuss trivial solutions and non-trivial only for homogeneous system of equations. In the rest of the cases, in case of non-homogeneous, we do not discuss normally about trivial solution or non-trivial. There we discuss whether it is consistent with one solution. Consistent, infinitely many. Inconsistent, no solution. But in this case, we always deal with trivial, non-trivial solutions. Therefore, in this case, in case of homogeneous, we expect only two cases. Let me write those two cases. Now you can see case 1 in this case is if rank of A equal to, you need not compare with rank of A slash B. This is for checking consistency. This is always consistent. You need not check out. So here B is null matrix. So rank of A equal to rank of A only. You need not check out. So compare rank of A with the number of variables. If rank of A equal to number of variables implies AX equal to O has a unique solution. Even I can say what is that unique solution. That solution is x1 equal to 0, x2 equal to 0 and so on, xn equal to 0, and that solution is called a trivial solution. Now case 2, just manipulate this. If rank of A not equal to NB implies AX equal to O has infinitely many solutions. Now out of all these infinitely many, one solution is trivial and rest of the things are non-trivial solutions. So therefore here I can write this one trivial solution, remaining or non-trivial solutions. remaining or non-trivial. This is very, very important for gate point of view. Note all these points. Next heading, homogeneous system of linear equations. Homogeneous system of linear equations. If RHS of every linear equation is 0, if RHS of every linear equation is 0, then it is called a homogeneous system. If RHS of every linear equation is 0, then it is called a homogeneous system. If RHS of every equation is 0, then it is called a homogeneous system. And this is denoted by Ax equal to O. And this is denoted by Ax equal to O, where O is a null matrix. Where O is a null matrix. Note, Ax equal to O is always consistent. Ax equal to O is always consistent because it has at least one solution. Because it has at least one solution, that is all variables are equal to 0. That is all variables are equal to 0. And this solution is called a trivial solution. And this solution is called a trivial solution. One more note. If at least one variable in a solution, if at least one variable in a solution is not equal to 0, if at least one variable in a solution is not equal to 0, then it is called a non-trivial solution. If at least one variable in a solution is not equal to 0, then it is called a non-trivial solution. Then it is called a non-trivial solution. Now note down this case 1 and case 2. Hope all these points are very clear. Now let me tell you one simple point. Suppose I have three equations involving two variables. Three equations involving two variables. Say for example, x plus y equal to 9, 2x minus y equal to 17, minus x plus 10y equal to, for example, 21. Now we have three linear equations in two variables. Now let us see what is coefficient matrix. This is 1, 1. This is 2, minus 1, minus 1, 10. Now look at the size of this matrix. 3 rows and 2 columns. Now what is the augmented matrix? A slash B. This is, at first let us write A, 1, 1, 2, minus 1. This is minus 1, 10. Now let us write right side matrix B, right side values. So it is 9, 17, 21. Now this is a 3 by 3 matrix. So here number of columns is 2. Here number of columns is 3. So one column will be excess. Now let us look at the size of this matrix A. It is 3 by 2. Now here we have three equations in two variables. That's why the size of the coefficient matrix is 3 cross 2. That means the number of rows represents number of equations in the coefficient matrix. The number of columns represents number of variables. Therefore, if it is a non-homogeneous, that is Ax equal to B or Ax equal to O, if the size of A is m cross n, it means that there are m linear equations in n variables. Note this point. If there are m equations in n variables, if there are m linear equations in n variables, if there are m linear equations in n variables, then the size of A will be m cross n. Then the size of A will be m cross n. And the size of A slash B and the size of A slash B augmented matrix will be m cross n plus 1, is m cross n plus 1, m cross n plus 1. Now let us discuss non-trivial solution in case of homogeneous system. One simple result. Earlier I told you, if rank of A not equal to number of variables in case of homogeneous system Ax equal to O, then this Ax equal to O has infinitely many solutions. Out of infinitely many, one solution is trivial and rest of the solutions are non-trivial solutions. Now let us concentrate homogeneous system Ax equal to 1. Suppose if the size of A is n cross n, that means the number of equations is n, number of variables is n. So in that case, this system will have non-trivial solution if rank of A not equal to number of variables. Here number of variables is n. For a n cross n matrix, rank not equal to n. This is possible only if det of this matrix is 0. This is very important thing to get non-trivial solution. See, here we are working with homogeneous system Ax equal to O. Assume that there are equal number of variables and equal number of equations. That means number of equations and number of variables is n. Now for a square matrix, A is n cross n matrix. The system is homogeneous system. Now if I want to say that this system has non-trivial solution, I can say rank of A not equal to number of variables. Now rank of A not equal to number of variables. For a n cross n matrix, rank not equal to n only if det A equal to 0. Note this point. If A is a n cross n matrix, if A is a n cross n matrix, then Ax equal to O. If A is a n cross n matrix, then Ax equal to O has a non-trivial solution. Then Ax equal to O has a non-trivial solution if det A equal to 0. If det A equal to 0. Now with this we have finished the concept system of linear equations. Now let us start classroom workbook on this concept system of linear equations, homogeneous and non-homogeneous. Just go through handout. Let us start with question number 72. Question number 72. See, in question number 72, there are two equations in two variables. So what are the equations? 4x plus 2y equal to 4x plus 2y equal to 7. 2x plus y equal to 6. 2x plus y equal to 6. It is given that the system of linear equations has options are like this: a unique solution, no solution, infinite number of solutions, exactly two distinct solutions. Now look at the first equation. This is 2 times of this. Now my original equation is 2x plus y equal to 6. This is my original equation. The equation is 2x plus y equal to 6. Second equation, the first equation is this: 4x plus 2y equal to 7. Now actually this equation is multiplied with 2 only on the left side. If it is multiplied with 2, this must be 4x plus 2y equal to 12. But this is a number other than 12. Therefore it has no solution. It is inconsistent. Very simple. So when you take 2 common here, take 2 common. Or when you go with analysis of ranks, the matrix A is this. You can reverse positions also. So here the order is given like this. So 4x plus 2y equal to 7. So 2x plus y equal to 6. Therefore the coefficient matrix A is 4, 2, 2, 1. Now A slash B is 4, 2, 7, 2, 1, 6. Now this is my 2 by 3 matrix. Here rank of A equal to 1. But here rank of augmented matrix A slash B equal to, look at the det of this 2 by 2 submatrix. This is a 2 by 2 block where det is non-zero, rank is 2. Rank of quotient matrix is 1, rank of augmented matrix is 2. So both are not matching, so it is inconsistent. Inconsistent means no solution. That is by using rank concept. Or when you look at the equations, this equation is multiplied with 2 only on the left side, but right side it is not a right number. If the whole equation is multiplied with 2, whole equation completely, when the constants are given right constants, then it has infinitely many solutions. If it is 12, then this system has infinitely many solutions. But a number is given other than 12, therefore it is inconsistent. That means no solution, not this. Now let us move to question number 73. Consider the system of linear equations. The equations are like this: 2x2 plus x3 equal to 0, minus 2x1 minus x3 equal to 0, minus x1 plus x2 equal to 1. So the options are like this: unique solution, no solution, only two distinct solutions, infinite number of solutions. Here on the right side of the last equation we have a non-zero number. Therefore this is non-homogeneous. So this is a non-homogeneous system of linear equations because of this non-zero number. Now let us try to calculate rank of A slash B, and let us try to compare with number of variables. Here we have 3 variables. So variables are x1, x2, x3. Here there is no x1. That means its coefficient is 0. x2 coefficient 2. x3 coefficient 1. Here x1 coefficient minus 2. There is no x2. So its coefficient is 0. x3 coefficient minus 1. x1 coefficient minus 1. x2 coefficient 1. x3 coefficient 0. Now augmented matrix A slash B equal to, so 0, 2, 1, 0, minus 2, 0, minus 1, 0, minus 1, 1, 0, 1. Now this size is 3 by 3. Now the size of this matrix is 3 by 4. Now here this A is a skew symmetric matrix. Now size is 3. Now this is 2 minus 2. 1 minus 1. Minus 1 plus 1. So this is a skew symmetric matrix. That means A equal to minus A transpose. Therefore since this is a skew symmetric matrix, its det is 0. This is a skew symmetric matrix of odd size. This 3 is odd number. So we know that the determinant of a skew symmetric matrix of odd size is 0. So det is 0. For a 3 by 3 matrix, det is 0 means rank cannot be 3. But when you look at this 2 by 2 block, it is a 2 by 2 submatrix where det is non-zero. Therefore, the rank of this matrix is 2. Now, the rank of this coefficient matrix, we got it as 2. Now, let us try to find rank of augmented matrix. It is a 3 by 4 matrix. For a 3 by 4 matrix, maximum rank will be 3. But there one column is excess. So, what we need to do is eliminate any column. You will get one 3 by 3 submatrix. If the det of that 3 by 3 submatrix is non-zero, then rank will be 3. If every 3 by 3 submatrix of augmented matrix has 0 det value, then rank cannot be 3. Then I go for rank 2 or not. Now let us see. Suppose I am eliminating first column. Then I am considering this 3 by 3 block. So it is 2 1 0, 0 minus 1 0, 1 0 1. Let us find the det of this. The second row has maximum number of zeros, or like this. Expand det value by using last column because it has majority number of zeros. So 1 into det of 2 1 0 minus 1. Now this is minus 2. It is not equal to 0. Therefore, what happened in case of augmented matrix is, this is a 3 by 4 matrix where there is a 3 by 3 submatrix whose det is not equal to 0. Therefore, based on this, we can say that rank of augmented matrix equal to 3. Got it? Rank of quotient matrix is 2, but rank of augmented matrix is 3. Both are different numbers. This is 3 and this is 2. Therefore, ranks are not matching. Therefore, it is inconsistent. That means it has no solution at all. Not this. Is this clear? Now let us move to question number 74. Consider the following system of linear equations. The equations are x plus 2y minus 3z equal to a. Second equation, 2x plus 3y plus 3z equal to b. 5x plus 9y minus 6z equal to c. What they asked, this system is consistent if 4 options are given. See, all options are given in terms of ABC. So consistent means rank of A equal to rank of augmented matrix. Since it is given that this system is consistent, implies rank of A must be equal to rank of augmented matrix. Now what is my matrix A? Coefficient matrix. That is 1 2 minus 3, 2 3 3, 5 9 minus 6. What is augmented matrix? A slash B equal to, this is 1 2 minus 3A, 2 3 3B, 5 9 minus 6C. Therefore, this is a 3 by 3 matrix and this is a 3 by 4 matrix. Now, let us find, to get the consistency case, rank of A must be equal to rank of A slash B. See, one interesting point in this question is, in matrix A, all numbers are given. In the coefficient augmented matrix, we don't know the values of A, B, C. But since it is given that it is consistent, rank of A should be equal to rank of A slash B. Rank of A slash B. Now let us try to find rank of this matrix. So to find the rank of this matrix, we need to find det of this matrix. Now this is 1 into, let us find this, Data of this matrix 3 into minus 6. So this is minus 18 minus 27 minus 2 into minus 6 minus 12 minus 5 into 3 15 minus 3 into this is 2 into 9 18 minus 15. So therefore this is minus 45. This is minus 27 into minus 2. This is plus 54. And this is 3. This is minus 9. Therefore this det value is 0. Since the det of the matrix is 0, rank should not be 3. But when you look at this 2 by 2 block, for example 2, 3, 5, 9. So its det is non-zero. For a 3 by 3 matrix, det is 0. Therefore rank certainly not equal to 3. Next, immediately I am trying whether the matrix has rank 2 or not. I am checking. When you look at this 2, 3, 5, 9, 2 by 2 submatrix, its det is non-zero. Therefore rank of this matrix is 2. Therefore, since the system is consistent, rank of A is rank of A slash B. But already we got rank of A is 2. Therefore, rank of augmented matrix equal to 2. Now, this is the key point in this question. Now, what is augmented matrix size? 3 by 4. But to get the consistency, rank of A should be matching with rank of A slash B. But rank of A equal to 2. Therefore, as per this case, rank of augmented matrix is 2. For a 3 by 4 matrix, rank of augmented matrix is 2 means what? Every 3 by 3 submatrix of this has det value 0. See, for a 3 by 4 matrix, maximum rank will be 3. But here I am saying that rank is 2. What does it mean? There is no 3 by 3 submatrix whose det is non-zero. That means every 3 by 3 submatrix of this has 0 det value. Therefore, implies every 3 by 3 submatrix of A slash B, every 3 by 3 submatrix of A slash B has 0 det. Therefore, you eliminate any one of the column. But as answers are given in terms of ABC, definitely you consider this column, and in the rest of the 3 columns you choose any 2. That is your switch. I am eliminating first column. So this is det of 2 minus 3A. This is 3, 3B, 3, 3B. 9 minus 6C equal to 0. Now let us simplify this. The data of this matrix. So this is 2 into 3C plus 6B plus 3 into, already we will get minus n, already minus is there. So plus 3 into 3C minus 9B plus A into minus 18 minus 27 equal to 0. This implies this is actually 2 into 3, 6C plus 9C. This is 15C. 2 into 6B, 12B. 12B minus 27B minus 15B. This is minus 45A equal to 0. So take C common, 15 common, you will get C minus B minus 3A equal to 0. Now let us see the options. Yeah, this is option number C. It is multiplied with minus C, so that you will get 3A plus B minus C equal to 0. So therefore option C is right answer. With this, I am closing the session. 6 more questions were left in the classroom workbook based on this concept. Let us discuss the